Yeah.
Star Wars themed.
Yeah, well, no, the wedding wasn't themed Star Wars. Oh, that's on the recording now. Okay, I gotta stop talking about that. So, all right. So, like I said, solving inequalities. I like this one. I think it's kind of a neat way that we do this. The first thing that we're going to investigate here with this stuff is figuring out if we have an equation of a polynomial and it's all factored out. How do we know when a polynomial is positive and when is it negative and when is it 0? You guys have done when it's equal to 0 so far, right? That's what you were doing yesterday. So you were taking an equation and figuring out when is it equal to 0. Well, now we want more information than just that. We want to know when is it 0, when is it above the x-axis, when is it below the x-axis, so where's that positive and negative stuff happening too? So before we get into like all the fraction type stuff, like the rational functions like we did yesterday, let's just look at a polynomial that's been factored out as far as it'll go. So let's say we've got something maybe like that. Okay, so the hard work's already been done of getting it all factored out. And so then I want to know when is f of x positive, negative, and 0. Okay, so let's start with the one we've already done before. If we have something that's all factored out, how do we determine where it's equal to 0? How do we use the factors to help us find where this thing is equal to 0? Okay, I'll help you out a little bit. Oh, go ahead. Yeah, so we use the fact that if any one of these factors is equal to 0, that makes the whole thing 0, right? So what number makes x minus 3 equal to 0? 3. So we'll start writing these down to get started. So our zeros are at 3. What makes x squared plus 1 0? Kind of a trick question. Nothing. Yeah, if you try and set this equal to 0 and solve, you're going to get imaginary solutions. Nothing works. So nothing there. What about this one? 2. So we have zeros at 3 and at 2. Okay? So if the zeros happen at 3 and 2, that means that those are the only places where this function could potentially switch from being positive to negative or vice versa. Does that make sense? Because it would have to go through the x-axis or back up in some way. So these are kind of like our turnaround spots, or at least they are potential turnaround spots where maybe it's going to go from positive to negative or from negative to positive. So do kind of a little visual here. So you make a number line and just make sure that these zeros are accounted for on there. So 2 and 3. So these are going to be where those zeros are. And then we're going to test in between. So if we pick some number less than 2, okay, everything less than 2 is either going to be all positive or all negative. Does that make sense? It can't swap anywhere in there. Otherwise, there'd be another x-intercept back over there somewhere, right? So it's either an entirely positive interval down there or an entirely negative interval down there. So if we pick any number that we want, less than 2, that's going to tell the story for us. So what's a nice, easy to work with number that's less than 2 that we could use?
-37.
Shut up, not negative 37. No, I like 0. Let's try 0. So we've got 3 factors here that are all multiplied together. So I'm going to just do with 3 little parentheses here. And then I'm going to indicate whether it's positive or negative with a little plus or a little minus for each one. So if I plug a 0 into the first factor, does that come out positive or negative? Negative, okay. So that's negative. The next one, if I plug a 0 in there, what do I get? Positive. And if I plug a 0 in here? Negative, but It's squared, so it makes it positive, right? Okay, so in that interval, no matter what other number I could have picked, I'd get this same exact pattern. The last one's always going to be negative, the middle one's always going to be positive, and the last one's always going to be positive, as long as it's a number less than 2. So what's a negative times a positive times a positive? Negative. So we know that that entire interval is negative. All right, and then we hop into the next little interval here and just repeat the process. Okay, so picking a number between 2 and 3, okay, maybe 2.5. Let's try that, okay? You can do this still in your head, I bet. If I plug a 2.5 into the first negative, into this one, positive, and into this one, also positive, yeah. So in this interval, I've got a negative times a positive times a positive, negative. Some of you are probably like, wait a second, shouldn't that have switched? Not necessarily. All right, we'll sketch a graph of this thing after we're done, and I'll show you. All right, so the last interval, anything as long as it's bigger than a 3, we're going to do the same little game. So first factor, what do we get? Positive. Second one, positive. Last one, positive. So positive times a positive times a positive. So that's a positive interval. Okay, so what's really happening here? The function is negative, then it has a 0 at 2, then it's negative again, then it has a 0 at 3, and then it's positive. So what does that look like? Well, it's going to be something kind of like this, if this is 2 and this is 3. So it's going to be negative, it's going to come up, have a 0 at 2, come back down, and then come up through 3, and then it's positive. Something like that. Okay? So those intervals still match, right? When it's less than 2, it's negative. Between 2 and 3, it's negative. Bigger than 3, it's positive. And it's still got those 2 zeros. Okay? So, in answering this question then, we're going to use some interval notation based on what we came up with, and this is called a sign chart, this thing. So based on our sign chart, we can give some intervals for positive and for negative. So what is the positive interval? 3 to infinity. And do I include the 3? No. Is right at 3, is that positive? Not technically, it's 0, right? So it's 3 to infinity. And then where is it negative? Well, we got to make sure it goes the right way though. So it starts at negative infinity. All right, so the lower number comes first. Now, technically, I can't go all the way to 3. Yeah, I got to do it this way. It doesn't include 2 because it's 0. Exactly. So positive is 3 to infinity, negative is negative infinity to 2, union 2 to 3. We've got those 2 intervals, or it's negative. Okay? So this is the basic idea of how we're going to approach solving some inequalities. Because what we just did there was basically solving an inequality. When I asked you where is it positive, I was asking you when is f of x, when is this equation greater than 0, right? And when I asked you where is it negative, I was asking you when is this function f of x less than 0. Those are inequalities. Okay? So we're going to look at some functions, and it's going to have 0 on one side, because that's how we can do this game when it's positive or negative. But we're going to be looking at some different inequalities with that. And then we're going to throw in some fraction work in there as well, too. So let's try another one here, and we'll see how things change. So let's do, I want to solve the following inequality. How about 2x plus 1 over x plus 3 times x minus 1. So again, I'm already factoring it for you. We're going to come across some later where you're going to have to do the factoring first, but I'm going to keep factoring for you now. And I want to know, when is this greater than or equal to 0? We're going to do that inequality. Okay, now because there's a denominator this time, there's some other things that we have to think about. We have a possible sign change when we have a 0. We talked about that in the last one, right? Could go from positive to negative or negative to positive if we have a 0. Potentially. It doesn't always work, right? In that last example, we found that. It doesn't have to switch, but sometimes it does. So we have to account for those. There are other places on a graph where a sign change could happen. Where else could a sign change happen other than a 0? What do I get from these guys down here? Vertical asymptotes. Think about that. A vertical asymptote, couldn't you switch from being positive to negative over an asymptote? That does happen, right? So what we need to do is we need to make our little number line again, and we need to place on that number line all of our zeros and all of our vertical asymptotes, because those are all the possible places where signs could change. Okay? So where are the zeros for this one then? Negative 1/2. Yep. And where are the asymptotes at? Negative 3 and positive 1. Okay. So let's go back to our number line here.